So, dear students, today we are going to discuss what are ally, what are its types, and what are the objectives of the ally. So, first we will discuss ally. What is an ally? In simple words, I may write down an ally is a homogeneous mixture. Homogeneous mixture of two or more metals. Two or more metals or mixture of metal with a non-metal. What we write? An ally is a homogeneous mixture. Homogeneous mixture is that type of mixture in which two metals or metal or the non-metals are heated up and they form an ally which cannot be segregated. Or in the simple words, if we may put salt in water, the salt particles are completely dissolved in water. That is called as the homogeneous. Heterogeneous. While on the other hand, if we may put sand on the water, it can be easily segregated, it can be easily separated. That is called as the heterogeneous, in which the solid particles and the solvent does not completely dissolve. So this is the ally. It is a homogeneous mixture. This means that the two metals are completely dissolved in each other. That is called as an ally. This ally can be best illustrated from its types. The ally are of three main types. One is called as the ferrous ally. Another is called as the non-ferrous ally. Non-ferrous alloy, and the third one is called as the amalgam. Now, what is ferrous alloy? The alloy which contains iron as one of its constituent are called as ferrous alloys. For example, I will give an example of steel. Steel is an alloy of iron plus carbon. As we know that in the pure form of metal, its strength is not so as compared to the alloy. Just like if I will give an example, if we melt this iron, it can be stretched. So, but when we add the carbon to the iron, it is durability, it is chemical property, and the strength of the hardness is increased. This iron contains in steel 99% is iron and only 0.5 to 1% is carbon. Why we are making these alloys? The basic reason is that the basic first fundamental how we can make these types of the alloys. The main constituent is iron. First we melt this iron. When we melt this iron, then we dissolve another metal or the non-metals. Here is the non-metal carbon. Then we add a carbon in a proper ratio to this metal. When we add in this, जब हम उसको एड इसमें कर रहे हैं तो उसके साथ साथ उसको रूम टेम्परेचर पे हम कूल डाउन करते हैं ताकि इसकी जो स्ट्रेंथ होती है तो वो इंक्रीज हो जाएगी. अब पहला जो है इसमें क्या है, मेन कॉन्स्टिट्यूएंट जो है वो आयरन. इट इज अ फेरस alloy. नेक्स्ट वन इफ आई विल गिव एग्जांपल स्टेनलेस स्टील. स्टेनलेस स्टील. अगर हम आयरन के साथ हम क्रोमियम प्लस निकल हम ऐड करते हैं, क्रोमियम निकल, तो उसको हम बोलते हैं स्टेनलेस स्टील. इसकी जो ड्यूरेबिलिटी वो उससे भी ज्यादा होती है और ये ज्यादा हार्डनेस भी इंक्रीज हो जाती है. हार्डनेस तो ज्यादा स्टील की होती है लेकिन जो इसकी ड्यूरेबिलिटी और केमिकल प्रॉपर्टी वो ज्यादा चेंज होती है. अब ये इट इज रेजिस्टेंट टू द करोजन, ये क्योंकि इसमें भी आयरन है और इसमें भी आयरन है. इन सिंपल वर्ड्स दोज alloys which contains iron as one of its constituents are called as the ferrous alloys, while the non-ferrous alloys are those alloys which does not contain iron as one of its constituents. Just like I will give an example of brass. Brass is an alloy of copper plus zinc. In this case, 80% is copper and 20% is zinc. Another example, if I will give bronze. Bronze, it is an alloy of copper plus tin. Here 90% copper and 10% is this tin. Listen, these two types of the alloys, brass and the bronze, these are the alloys which contains copper. One is called as copper and zinc, another contains copper and the tin. Here in both the cases, there isn't any sort of iron. So those alloys which does not contain iron as one of its constituent, they are called as the non-ferrous alloys. One example is brass and another is called as the bronze. And the third one is called as the amalgam. What is the amalgam? It is that type of the alloy which contains mercury as one of its constituent. Just like I will give an example of sodium amalgam. Second one is zinc amalgam. These are the two alloys which contains mercury as one of its constituent. When any substance, when any alloy contains mercury as their constituent, they are called as the amalgam. These are the three basic types. One is called as a ferrous alloy, another is called as a non-ferrous alloy, and the third one is called as the amalgam. Now, what are the objectives of these alloys? Why we are making these alloys? We are going to discuss now alloys of aluminum. There are some important alloys of aluminum. First one is duralumin. Duralumin. Duralumin is an alloy. It contains aluminum, copper, magnesium, and manganese. Aluminum, it contains 95%, copper contains 4%, and the rest two contains the 1%, 0.5, and this is also 0. This means that at place. Duralumin is an aluminum because the main constituent is aluminum. So we may call it is the alloy of the aluminum. So duralumin, it is the alloy of aluminum which contains these four important metals. One is aluminum, another is copper, and the third one is magnesium and the manganese. The percentage of aluminum is 95%, while the copper is 4%, and the manganese and the magnesium is 4%. As we know that this duralumin, it is very strong. It is very strong and its melting point is high. When it is very strong, it is used in manufacturing of jet aeroplanes, jets, or it has high resistivity to the corrosion. Even it cannot corrode with the salt water. So it is used in manufacturing of the ships. In simple words, you may write down that duralumin, it is an alloy of the aluminum which contains these four basic metals, and it is strong. As it is strong, so it can be used. It is strong as well as the light, so it can be used in the manufacturing of aeroplanes, jets, and the submarines, because it has the capability. It has so much resistance even with the salt water. One was duralumin, and another is magnesium. Magnesium. Magnesium is the another alloy of aluminum. It contains two main metals. One is called as the aluminum and another is called as the magnesium. One is called aluminum and another is called as the magnesium. Aluminum here, it is 95% and the magnesium is only 5%. So this magnesium, it is very strong. As it is very strong, so it can be used in manufacturing of the utensils like pressure cookers. As we know that if we may took aluminum in the pure form, its melting point is lower as compared when we combine magnesium and the aluminum, so its melting point increases. When its melting point increases, so we can make, and its strength also increases, so we can utilize such type of alloy for manufacturing of these things like utensils, pressure cookers, etc. And the third important one is alkeno. Alkeno is the alloy of, it contains aluminum, iron, nickel, cobalt. These are the four main metals When they are combined, they form an alloy which is called as the alkyno. Because the basic metal here is that is aluminum, so we may treat it as the alloy of the aluminum. Although it is a ferrous alloy, some may ask you because it contains iron, it is a ferrous alloy, but it is the alloy of the aluminum because the main constituent material is that aluminum. This alkyno have the high it is mostly used in the manufacturing. It has the property of the magnetize. So we are making such type of alloys for the manufacturing of the magnets. Hope so you have understand it. Thank you. Dear students, we will discuss now objectives of the alloy. What are the objectives of the alloy? As I have already mentioned, there are so many objectives of these alloys, but the important one is that first one is to increase the resistance of the corrosion. To increase the resistance of the corrosion. Just like I will give an example of stainless steel, or we may say stainless steel. As you know that the stainless steel contains iron as one of the main constituent. If we may put this iron outside, it may react with the oxygen molecules, or it can react with air molecules, that water molecules that are present in the atmosphere. So there are high risk of the corrosion. But when we add the chromium or nickel or something else and making the stainless steel, so its resistance to the corrosion is increased. This means that now there isn't any effect of the corrosion, because these type of the combinations, when iron, chromium or a nickel are combined together, they form the stainless steel. It does not react with the oxygen molecules or the water molecules present in the atmosphere. So we can prevent such type of the things, which our aim was to increase the resistance regarding this corrosion. The first one is to increase the resistance to corrosion, क्योंकि इससे मतलब corrosion नहीं हो सकता है. तो दूसरा जो है to modify the chemical reactivity. As you know, there's potassium, sodium, magnesium. These are the highly reactive metals. Even they can react with the oxygen. They are reactive with this water molecules or anything else. That is why you know that this sodium is always kept in the kerosene oil. So if we may put this sodium, if we may make an alloy of sodium with the amalgam, or we may say mercury. If we make an alloy of sodium by adding mercury, so it makes sodium amalgam. Sodium, it is chemical property totally changed. So it was in the pure form, the sodium have the high reactivity, but when it combines with the mercury, its chemical property, or we may say the reactivity, decreases automatically. This is the another objective of this alloy. The third one is to increase the hardness. As we know that the steel, it is a combination of iron and the carbon. Listen, we have already discussed that if we provide heat to the iron, it will melt automatically and we can stretch them. But when we add iron, we add carbon to the iron, its strength is increased, so that it can be used for the construction purposes, just like the railway bridges or something else for the building purposes. That is the reason. So we are making to increase the strength. This is the basic objective of this alloy. And the last one I have discussed, to lower the melting point. There is an alloy whom we call as a solder, which can be, when its melting point is decreased, so it can be used in the welding purposes. If we may take a pure metal, its melting point is high. When its melting point is high, we cannot use such type of the metals for the welding purposes. But when we make such type of the alloy, just like the solder, its melting point is lower down. When the current is passed through it, it melts and it is used for the welding purposes. Hope so you have understand it.